Alrighty, welcome back. It's been a while since I've done one of these, so let's see if I still remember how to make a video and do it correctly. For those of you who are either joining us or maybe didn't use the videos like you were supposed to first semester, I just want to reiterate the fact that this really makes a big difference in this particular subject. You guys don't have the benefit of looking back to last year at my students, but I do. Finals went up 6%. That's a humongous increase. The final average across all three classes, I believe, was an 88% this year and 82% this last year. So that is a humongous increase for a final. It's awesome for you guys. You guys made big strides throughout the year once you got used to the videos, but there are still some of you that need to make more progress when you watch the videos and need to do a couple other things. For those of you that are joining us and this is the first time you've watched a video, there are a couple things you want to make sure you do. First of all, make sure you are keeping the sound on. Make sure you can hear it. If you try and watch it in study hall without headphones or something like that, it's really difficult to get everything that you need and all the information that you need, because there's a lot of things that I say that you need to make sure you either write down or you make notes of, or you flat out just need to hear. Okay. Secondly, make sure you're watching every part of the video. If you are skipping around, skipping back and forth, that's only hurting you guys, and you guys know that. So you got to make sure you're putting in the work. Again, last year, kids were spending 45 minutes, an hour and a half on some of the homework. You guys spend about 15-20 minutes on some of this stuff. So it's not a ton that I'm asking you guys to do, but it's only so that you guys can do better in this class. Again, make sure you guys, as you watch them, you work ahead if you want. You pause, you rewind. Again, this is your tool, however you want to use it. Use whatever you need to in order to be successful in this class. If you don't understand something, okay, obviously I'm not next to you, but you can make a note, you can put a little star, and then you can go ahead and you can write it down, write down exactly what your question was. A lot of times you think, oh, I'm going to ask them tomorrow in class about this, but then you forget what the question was. So just make a note of that, and then when you ask me in class, I'll probably know what you're talking about, and we can look at it and go over things. So make sure you guys have questions that you want to ask. If you guys don't have questions, I'll just assume that you know the video, you understand what was going on. Okay. So those are a couple things that you want to make sure you're paying attention to. And then again, if you ever have questions about how to watch it or you can't get to the video, feel free to email me. There's no excuse for not having everything done. When you come in the next day, everything on your note should be done unless I say otherwise. So assume this entire page, which in this case, this entire page will need to be done. There will be a problem at the end that I ask you guys to do for tomorrow. You'll have to come in tomorrow with that problem done, and that's how you get your credit for your notes. Every single thing needs to be done on your notes. I need to see that you did it, you didn't copy it down. Again, copying it down is only going to hurt you guys. So, let's get started with this one. This is a pretty good one to look at to start off the new year. Not too long, it's only going to take us a few minutes to get through. But very similar to what we've done back in semester 1 with Polygons. So, first of all, in class we talked about ratios and proportions, and we're going to use that in Polygons today. So we're actually going to use some of that simple math and apply it to some of these polygons. So first of all, what are similar polygons? Well, you guys probably know what this word similar means. Basically, it's something that's close to another shape, or you would say, you know, my left arm is similar to my right arm. Is it the exact same? No, but it's similar. So a similar polygon is figures that have the same shape but not necessarily the same size. So that's what it is in geometry. Two polygons are similar if and only if, there's that if and only if biconditional statement, corresponding angles are congruent. So you still need all the angles to be congruent, because that way you have the same shape. But their corresponding side lengths are proportional. That goes back to what we talked about with proportions. So you can't just have random side lengths, they all have to match up in some proportion, and we're going to get to scale factor and all that here in a second. So you might see something like this. Draw a diagram and identify the congruent angles and proportional sides. Okay, so let's just draw a couple diagrams. Notice one's bigger than the other. A, B, C, D. If we label it from left to top right to bottom left, we have to do the same thing over here. So E, F, G, H. And then we want to identify the congruent angles and proportional sides. Well, then D and H are congruent, C and G are congruent, B and F are congruent, and then I'm going to do one of these over here for A and E. Okay, that's showing all those angles are congruent, which goes with our definition. And then the sides that are proportional, we don't want to do this. We don't want to mark them like that because that's showing them that they're the same. So what we'll do in this case is we can just say that, maybe I'll highlight. So AB would be proportional to EF. FG is proportional to BC. HG is proportional to DC, and AD and EH are proportional. Okay, so those are the sides that match up, and we're going to get to how that proportion works here in a second. Determine whether the polygons are similar. If so, write the similarity ratio in a similarity statement. Okay, so we're going to look at these and decide if they are similar polygons. Now, the way I like to handle these is I almost always redraw them, at least until you guys get a good hang of it. I would suggest redrawing it. Doesn't really matter which one you redraw, but it is a good idea to redraw. So I will go ahead and redraw that smaller one, which I didn't do a very good job of, and make sure I label everything the way it was. So we have E was our right angle. Now we have to be careful here. E to D was our shorter side, so that's going to be, D is going to be here, F is going to be there. So this is 31 degrees, FE is 5, and DE is 3. I don't even need this picture now. Okay, I have a brand new picture and makes everything line up perfectly, so I don't have to screw around with tilting my head and doing all that stuff. So might help you out a little bit. Now we want to decide if we have a similarity ratio or a scale factor, and then we can go ahead and write the similarity statement. So let's look at these. First of all, are all our angles the same? Well, we have a 59 degree, 90 degree, and then this would have to be 31 degrees up here. That gets us to 180 degrees. Then down here you can see that this is going to have to be 59 degrees as well. Excuse me, I'm coming off a little bit of cold. Okay, so we have all congruent angles, which we need to have, so we know for sure that the angles are congruent. Now we need to look at the sides. Well, if BC is 6 and ED is 3, and AB is 10 and EF is 5, you guys can see what's happening from the top shape to the bottom shape. We have a similarity ratio or scale factor of 6 over 3, or 10 over 5, or what we would say as 2 over 1. That's the one we would want to use. It's a simplified scale factor or similarity ratio. For every 2 inches or whatever unit you want to use for the top triangle, the bottom one only gets 1, and that's how we have our similarity ratio. We would then say, in any order that you want, that we could go, okay, ABC, triangle ABC, is similar to triangle, and then you have to match it up, FED. You could also go triangle BAC is similar to EFD. There's a number of different combinations you can use. You just have to make sure that you're matching up everything. So that's how you get your scale factor. You go from one triangle to the other, see how you get from one to the other, and then always simplify that fraction. And then your similarity statements, just like writing congruency statements when we did that back in chapter, let's see, 5, I believe, last semester. Let's look at a couple more polygons, and we're going to now use those proportions that we looked at on the first day to solve some of these missing sides. Okay, so we know that parallelogram, actually these are just a quadrilateral ABCD is similar to quadrilateral PQRS. So you know everything matches up. A goes with P, B goes with Q, and C goes with R, and D goes with S. Make sure you always know that they're the same way. If not, rearrange them. Okay, so we want to find, let's see, x plus 1. We need to find the x at some point. We want to find the angles, BC, and the similarity ratio. Okay, so first of all, let's take care of the angles. The angles are probably the easiest thing, and then we'll get to x plus 1. So if this is 33 degrees, that's 33 degrees. This is 87 degrees, that's 87 degrees, and then let's see. Hopefully you guys remember we need 360 degrees in a quadrilateral, so let's see what 360 minus 87 minus 90 minus 33 gives us. Hopefully you guys did it. 150 degrees here. Okay, so that's not too bad. We already found all the angles. We want to find BC. Well, only way we can find BC is if we know what x is. So this is where we're going to have to use are proportions. And again, there are a lot of different ways you can set up proportions. You can go ahead and do these in a number of different ways. Again, just kind of how you want to look at it. It really depends on how you see it. I'll kind of change it up just because I see it differently for different problems, and to give you guys an idea that you really can do it in a number of different ways. So you just want to make sure you're really matching things up. So in this case, I'll do it like this. We have ABCD is similar to PQRS. Okay, and we're going to set up a proportion. All we want to do is make sure we keep things on the same side. So if I want to find x plus 1, I know I'm going to have to compare that to 12 at some point. Okay, so we have x plus 1 here, and that's going to be equal to or match up with the 12 from the right figure. Okay, because they're both the right sides of the figures. So x plus 1 is going to be proportional to that side of 12. Now we have to use information that we already know so we can find x. We already have one variable, so we can't use another one. We know that this side's 36, this side is 8. So ABCD has a side of 36, and PQRS has a side of 8. Those match up. And now you go ahead and cross multiply. Keep parentheses around this, so we have 8 times x plus 1 equals 36 times 12. Distribute 8x plus 8, don't forget to distribute to the second term, equals 36 times 12, gives us 432. Subtract 8 on both sides, 8x equals 424. 424 divided by 8 is going to give us 53. So x is 53, which then means that BC would be 54. And to find the similarity ratio, now we're going to go ahead and basically find that scale factor. So from one figure to the other, what's the scale factor? You always want to go in the order that you're given. So we're going from left figure to right figure. So we can pick any fraction that we have. We could say 36 over 8 or 54 over 12. They're the same. So we'll go ahead and say your similarity ratio is going to be equal to, again, 54 over 12, 36 over 8. They're both going to give you, if you divide them, let's see, it's going to come out to a decimal. If we do it, you can hit math frac, or you can just divide by the greatest common factor. So we have 36 divided by 8. That's going to give us 9 halves if we divide it by top and bottom by 4. And again, you can do that a number of different ways. You can also do it on your calculator. So what we're saying is for every 9 units the figure on the left gets, the figure on the right gets 2 units. And that's how that one works. Okay? So we could figure out PS if we wanted to, but we don't have to. Okay, one more, and then you guys are going to do number 5 for the rest. BIL is similar to ODN. The scale factor is 8 to 3, so for every 8 units BIL gets, ON or ODN gets 3 units. Again, first thing I would do is probably just redraw to make sure that you know exactly what you're looking at. B goes with O. You can see it here, so make sure you do that. So O is up here. I goes with D. So let's make sure we get D in the right spot, and then N would have to be here. X goes on ON's side, and I'm going to get rid of that. Again, if you don't want to do it, that's fine, but I would strongly suggest redrawing them so that they're facing the same way. We want to find ON. Okay, so that's our missing side. And let's see, we know the scale factor is 8 over 3. So look at what you have. We know that BL is 24, we know that IL is 20. We know that ON's X, we don't know what DN is, so we don't really have a proportion we can set up just using the sides. So we have to go back to that scale factor. So again, the way you'd want to do this is compare the two shapes. So you have triangle, and I'll do it this way this time just so you guys can see it a little bit differently. You have triangle BIL, and you're going to compare it to triangle ODN, and you're going to set up a proportion, notice how I'm just putting them on the side now. Again, there's so many different ways you can do this. I don't want you guys to be restricted to just doing what I do. So triangle BIL, that would mean for every 8 units that BIL gets, ODN gets 3 units. Okay, because that's our scale factor. For BL's side of 24, ON is going to be what? That scale factor is going to allow us to figure out exactly what ON would be. So again, this part right here is your scale factor. This part right here are your sides. So again, you're using your scale factor to find your sides. So we're going to cross multiply again, and it turns into a pretty easy problem after that. So you just have to make sure your proportion's set up in a way that works. You want to make sure everything is lined up. So we have 24 times 3, so we have 8x equals 72. So x equals 9, which is ON, and that's the missing side. I have one more left for you guys. Again, this is the one that I want for tomorrow. If I say that, that means it's due tomorrow so that you can get your full points. Okay? If you don't know how to do it, come in early, ask somebody right at the beginning of class. But again, if you're watching the video and you're doing your notes, these should not be difficult problems. There are 2 regular hexagons. One has side lengths of 15 and one has side lengths of 8. Draw the diagrams. Are they similar? If so, what is the scale factor from big to small? So very simple problem. Make sure that you guys can do it. Make sure you guys draw the pictures and then make sure you explain your answer for tomorrow. Welcome back.